So I guess let's go ahead and begin then. So, today I will be showing how to make a Sega Saturn splice cable to be used with RetroSpy, which is a input displaying program. Basically, the goal of this is to cut this cable apart and then splice these wires into the connections in the cable, so that that way these wires can go to a microcontroller, and then you can continue to send the controller to your console. So let's begin, I guess. So very first step is to test your extension cable and make sure it works before you start cutting it up, because if the cable never worked to begin with, you're going to have a tough time figuring out why it doesn't work once you've cut it up. I've already done this though, so I know that this cable is good. But from there, you take the female end of the cable, and then I'd like to, I don't know, what, 1, 2, maybe 3.5 inches I go away from the female end. So about that much, right? And then this is where I'll make my cut. And the idea of this is that if you want the microcontroller closer to you, you cut on the female end. If you want the microcontroller closer to the console, you cut on the male end. But since usually you're going to be at your computer and not at your console, we're going to use the female end. Make sure you get that right, because that's pretty much the only step you can't redo. So, I mean, you can always redo it, but you don't want to. So yeah, I'd choose the female end, maybe about 3.5 inches, and then you just make a cut. Try to make it as straight as possible, obviously. Did I mention this cable costs $35? Anyway. Let's just ignore the fact I'm cutting up a $35 cable. That's fine. Okay. So now the next step is we need to pin out this cable. What I mean by that is that we know there's pins 1 through 9 on the female and male end of the Saturn controller extension, but now that we've cut it, you're going to see all these wires inside of the controller, and a lot of people will use standard practices for any kind of electronics cabling, like making black ground and red 3.3 volts, you know, stuff like that. But especially where a lot of these controllers are coming from China, you can't be guaranteed of that. And especially for a controller like this that's not very common, you're not really going to have a standard to look at. So what we need to do is use a continuity meter and pin out all 9 wires inside of this cable. So we're going to go and do that. I already have a pre-made little reference sheet here for myself so that I can remember what color goes to what pin, and then eventually what DuPont wire correlates to which pin. So this is kind of where you need to make a decision that's going to affect the rest of the project. So you're going to strip off jacketing from this controller. My recommendation is about 1 inch and change, I believe, right? Maybe right at 1 inch. Yeah. So yeah, you want to strip it maybe right at 1 inch and take all the jacketing off of the controller. And I just use these snips to do everything for this project. I'm sure there's better tools, but this is just what I'm accustomed to using, unfortunately. Be very careful. If you mess up the male end doing this, you can always just cut a little bit off and start again, but since we only cut, 6 inches or so from the female end, we need to be very careful that we do this right the first time, otherwise we're going to have to cut some of the female end, and we don't have much to work with. Did I mention this is a $35 cable I'm cutting into right now? Did I mention it's not for myself and someone's paying me to do it? Did I mention I'm totally not nervous at all? Even though I've done this tens of times now. It's fun. Alright, we're almost there, I think. The jacketing on this is legit. Holy crap, man. Although I need to not be doing that. That's not good. Ah, this urethane jacketing. Come on, bud. Oh, there we go. And I missed the wires. Hell yeah, we're in. We are in. Oh, I did nick a wire. We'll be alright. We'll figure it out. Alright, so jacketing off, right? And then you should be left with your exposed wires. Like this. So yeah, I did nick that yellow wire, but it looks like I just got the jacketing, which is good, because that's all we really need to do anyway. I'll touch that up when we are closing this cable back up, but it should be fine. Because yeah, there's literally no metal was cut into, so we're good. But yeah, definitely to take a look and make sure you didn't cut into anything before you continue, because otherwise you're just wasting your time. So now you can either try to probe this without stripping these wires, but you need to strip them anyway, so I would suggest just doing it now, and you're going to use the same tool to do that, or at least I do. And when you strip the jacketing off these wires, you want it to be the same jacketing taken off from each wire, so that the same amount of copper is exposed on each wire. And you can probably get away with doing these a couple at a time. How long? I like these about, I don't know, 1/3 of an inch maybe. Yeah, maybe about 1/3 to 1/2 inch of exposed copper on each line. I don't know if you can see that or not, but yeah. So you can see the copper is exposed, and we just need to do that for each line. Alright. So there are exposed copper connections on each line. So now for this step you need a continuity meter, which I luckily own, because otherwise this would be a pain in the butt to do. So yeah, I guess I can teach you all what a continuity meter does, just in case you've never done something like this before, but again, I'm trying to explain this so that anybody can do it, so you should learn how a continuity meter works and what it's for. So a continuity meter, surprisingly enough, shows if there's continuity between two diodes. So for example, if I take just a jumper or something I have laying around here. So simply if I put one end of the wire on one probe and one end on the other, it should make a noise. Like that. So pretty much now we just do this for each pin on the controller, and we'll know which color wire goes to which pin. So let's begin. This is kind of hard to do by yourself, but we'll make it work. Alright, so it looks like brown is pin 1. Hi DJ, welcome. Hey Homestar, nice to see you. I guess I'll be seeing you soon, actually. That'll be fun. Alright, second pin. Alright, green. Yeah, it has been a while. Hope you've been well, DJ. Pin 3. Alright, pin 3 is red. Yeah, that's what James was telling me. He said you needed a job first. So get on it, I guess. Alright, pin 4. Alright, pin 4 is blue. Well, it seems like he's not wrong, so... Pin 5. Alright, pin 5 is orange. Yeah, that makes sense. Pin 6. Yellow. Pin 7. Black. Alright, so this should either be gray or white for pin 8. It is gray, which leaves pin 9 as white. Great. Okay, so there's our pinout. Okay, sounds good, man. I guess there's a possibility that I actually reversed these two. I needed to check to see where the reference is for a Saturn controller. Looks to be on the female end, so I'm good. Cool. Alright, so we're done with the pinout, so we can put the female end of the controller aside. Now we just need to strip the jacketing and then the leads on the male end. By the way, like I had mentioned earlier at the beginning of this video, I've done probably tens of these now, probably 20 maybe at this point. This is by far the most expensive cable I've ever cut up, but also the nicest cable I've ever cut up. So it feels silly, I guess, but at least for on the internals, this seems to be a pretty nice cable compared to others that I see. So perhaps it's worth it. Anyway, let's strip the jacketing on this one. And now that you've used your female connector and stripped that, you can use that as a reference for the other one. And make sure you measure it from the top of the copper, not the top of the stripped jacketing, because that would be an easy mistake to make. Little score right there. That should work. Perfect. That definitely looks unscathed, so let's just be careful. Yeah, that's a good cut, baby. Much better this time. Man, this jacket is strong. Wow. Yeah, this is a really nice extension cable. I wouldn't pay this much for it, but if you like the Saturn, this is a really nice cable to work on. Hey Kios, welcome. Just making a splice cable from start to finish. So again, we're just going to strip the jacketing on the leads on the male end, just like we did on the female end. And make sure again to make the exposed copper length identical to the one on the female end. Otherwise, it makes things a little bit harder. I wouldn't recommend it if you can help it. There we go. Alright, so at this point, this is what we should have. So we have your male and your female end. Both of the jacket of the extension cables are exposed, and then both of the jackets of the leads are all exposed. So now we're ready to begin the like the splicing part of making the cable. So to describe this step in full, and then we'll kind of do it step by step from there, we're going to be connecting each of these wires back together. Even though we just cut them apart, we're going to just connect them right back together. And then all the signals that we need to tap into, we will solder a DuPont cable onto it. And then for the ones that we don't need the signal from, we just will close those up. We'll just solder them back together and eventually put jacketing over it. So yeah, this is by far the most time-consuming part of this project. So it's gonna be pretty chill from here, and I'm gonna be pretty busy. But feel free to ask questions or anything if you have any. But this definitely takes a lot of patience and concentration. So yeah, all you're gonna do is I'll show you the first one and then I'll do the rest on my setup here. So let's start with orange, let's say, right? Okay. So all we're doing here for this part is you kind of want to fray the copper on both sides, like fray it apart. Spread the strands apart on both ends. So it's kind of like fanned out. And I like to use tweezers a lot during these steps to just move things out of the way and isolate. So like we can isolate these two orange wires like that. And then you just want to twist them together. So like get them all mixed together and then just hand twist. Oh yeah, I guess we are soldering here. So I'll go and turn on my soldering iron. But yeah, I like to use my little regulated soldering iron here. I have it set to 300 to 23 degrees Celsius. Anywhere between, 300 and 320 is going to do just fine just for this kind of stuff. So now that we have our wires twisted together and a good connection, we're going to solder them together so that they never come apart, and it'll give us a good solder point to solder our DuPont wire onto. So for here, I just have some rosin flux. This is what I like to use for connectors and just a tin stuff. So just a little bit of flux on there. And then get our solder. If I can find where the end is. If I can find where the end is. Just looks like a ball of metal now. Oh, there it is. Alright. Alright, so I'm just using 70-30, nothing crazy. And we just solder the two wires together. So we take our iron, turn it off, and throw a little solder on there. Maybe. Take. Hello, iron. What is happening? There we go. Okay. Just get a little solder on there, like that. And then just paint the wire with your soldering iron. You don't have to do anything, just paint the wire on each side. So just one stroke across, maybe a couple strokes like that, and then a couple strokes on the back side. Just so that the entire thing is covered in solder. It's always better to put more than less. for this. Alright, and then as you'll see, now we have a soldered connection. Now we do this for every single wire. If this were pre-made, this is when we'd be fast forwarding like the pros do, but this is live, so you get to see all the mistakes, all the frustration live. Just so you can see what I have to deal with when I make these, and why I'm not going to be making them for people anymore. Hence why I'm doing this today, so that you can do it yourself. I think my tip is dying on my soldering iron. It's not taking heat very well. Two down, 7 to go. Until we have to do this again. It's fine. I can't emphasize how nice these wires are on this controller extension cable. This is so nice. When you buy these crappy Nintendo extension cables from China off eBay, man, these copper parts are, there's so little copper, man. You really have no idea how small the copper is on some of these crappy cables, but this is quite nice, so I'm enjoying this. Three down. 4 down, 5 to go. Five down, 4 to go. Six down, 3 to go. That's 7. This is when stuff starts getting hard because everything's in the way now. But yeah, when you get controllers like SNES, NES, N64, GameCube, any like the less pins the controller has, the quicker and easier it is to do this, obviously. But unfortunately, the Saturn has 9 pins, which is the most of any common console, unfortunately. Or, excuse me, the PlayStation also has 9. TurboGrafx is DIN 8, I believe, and then everything else is 6 or below. Oh, and then you have Genesis, of course, but that has a very, very, very common connector on it, so you can do a lot of easier stuff with the Genesis. But in terms of stuff you have to cut up yourself, Saturn and PlayStation and TurboGrafx are the biggest pains. But I'll do an N64 any day. That's like the only input display you can ask me to do any day of the week, and I'll probably do it. Anything else, man, it just takes too much time for me. Ohayou gozaimasu. Konnichiwa, virgin butter. Too handsome? I haven't even shown my face today, man. Although, I am light today. I weigh less than I usually do today, so I am feeling kind of hot, I guess, today. Right? Self-love. Hashtag self-love, right? Well, that might get you some bad results, actually. Don't search hashtag search or self-love. Don't do that. I didn't think about that before I said it. Alright, last one. Alright, and that should be the last wire. So, perhaps if you can see. Alright, so those are our 9 wires all soldered up, which is good. It's a good thing. Okay, so that's that step complete. Now next step is going to be almost the exact same thing as this step, except instead of soldering 2 leads together, we're going to solder the soldered 2 leads together to DuPont wires, these guys. Now if we look at the documentation for RetroSpy, that would be my dashboard. That is not RetroSpy, actually. If you all didn't know that, that is not RetroSpy. However, see, that's my actual dashboard. Where is? Ah, there it is. Yeah. So if you look at the documentation, we're on the GitHub page for RetroSpy. Yeah. If you scroll all the way down, we're doing Sega Saturn today. And we've pinned out the controller, right? 1 through 9. So we need to look at this table for Sega Saturn here. And so like pin 2 goes into the digital pin 3 of the Arduino. But you'll notice signals 1 and signals 9, which I believe are VCC out and ground, right? VCC out, ground. These two are not used. So these two, we don't have to do anything else for this step. But pins 2 through 8, we will need to solder a DuPont wire onto each of those pin numbers. So we need 7 DuPont wires, so I'll go ahead and get those. And I'm actually going to do Shintalk a favor here, the guy who I'm making this for. So let's see, 1, 2, 3, 4, 5, 6. And then I could use like black as 7, so we'll do that. So there's 6 there, and then, do I want to be nice and give them a white one? Oh, they messed up the paint on that one. Yeah, okay, we're giving them a black one. Black it is. Okay. So what I'm going to do is I'm going to make this cable so that when the user has to plug this in to the microcontroller, the order of the cables will be rainbow. So instead of having the user to have to remember which pin goes to which socket on the Arduino, all they'll need to do is just put them in the order of the colors of the rainbow. And then you never have to think about which one to plug into where. So let's go ahead and pin that out then. So pins 1 and 9 are null. Okay, so the first one would be 2, so pin 3 needs to be red. The next would be pin 2, so that would be orange. Pin 4. Green. Blue. Purple. And black. Okay. So that's our pin out. Now we just need to do it. So for this step, remember when we were doing the connectors here, we were twisting them together and then putting flux on it and then putting solder over it. This, I do the exact same thing, except I just put flux on one end of the DuPont wire. I tin this and then I solder it together. So that's what I'll be doing for each pin. So let's begin. Gray is pin 8, so that gets a yellow wire. Alright, so like I said, just like before, put some flux on the end of the DuPont wire. Right, and then when you tin these DuPont wires, you have to be careful because you'll notice this black part here is plastic. It's pure plastic. So if you have the soldering iron on there too long or too close to that, it'll melt it. Now, do note this is the end that's going into the cable. This isn't the end going into the Arduino, so it doesn't matter too much, but I don't like melting things that don't need to be melted, so I don't melt it. So we have our DuPont wire fluxed. We're just going to tin it, so just put a little bit of solder on there. You just want a teeny tiny bit on there, just enough to start a connection between the DuPont wire and the controller wire. Alright, so we have that tinned, so now we just put the wire right next to the 2 wires we already soldered. Make sure you're not soldering make sure the plastic isn't touching the wire, make sure it's always just metal on metal connection. And then just melt the 2 soldered points together. I guess I should clean my tip first, because that's not taking. And I should probably put a little bit of solder on my iron. Just like that. Perfect. Alright. And then, once you have the wire on there, just make sure you give it a good light tug. And you'll notice that thing's not going anywhere. So that means we have a good soldered connection. And if you want to be really super, like maybe this is your first cable, if you want to be like super preventative in terms of testing, you could bring out that continuity meter we had earlier, and you can do a continuity test between the end of the DuPont wire and each lead if you'd like. But I've done this a lot, so it should be good. So that's what you do for each wire that needs a DuPont wire. So we will continue to do that with the rest. So next is blue. Blue is pin 4, and we said pin 4 still gets blue, so that's pretty easy. By the way, I definitely should have mentioned that this is going to be the part of the project where if anything goes wrong, this is where your project will go wrong. Like when you're testing it and something doesn't work, it's a very good possibility that you just don't have a good connection on your DuPont wires. Hello. Alright, so orange is pin 5. Pin 5 gets purple. Do I not have purple? What happened to my purple wire? Yeah, I'm missing. Oh, that's just hiding. Okay. Soldering scares you? Don't let soldering scare you. That's what I used to say, and now look at me. It's how many successes start in life, right? I'm scared, but let's try it. And then you end up successful. Why does it scare you? I mean, you're gonna hurt yourself. I've definitely hurt myself doing this. Don't get me wrong, but eventually you get good enough so that it never happens. And by that point, you're doing great things in life, so. It does just take practice. I mean, this is... Okay, look, for real, guys, you want to know how I got into soldering? I worked at a video game store, and I saw them replacing batteries in Game Boy cartridges, and I said, that looks cool, would you let me try that? And now I'm making input displays. That's how it went. I guess I take that back. I did Game Boy batteries, then I did console RGB mods, then I did input displays. Point remains though. It's all the same skill. Oh yeah, I've definitely burned myself. I mean, look. Where can you see it? Maybe not. Oh yeah, there it is. You can see it. We make accidents, all right? But we grow stronger from them. Green is pin 2. Pin 2 gets orange. Yeah, like that's another great example, Shadow Killer. I may or may not have not been sober one night and decided that there was a cable behind my computer that I needed to cut with scissors. Turns out I cut the wrong cable. If I did not know how to solder, I would have not been able to repair that cable. It's a very good skill to learn how to do, if you have any interest in electronics at all. Ow, that hurt. See, we hurt ourselves, but we're good. We're good. We're good here. Oh, hi, Anapause. Welcome. Oh, it's just a little piece of solder that fell onto my finger, guys. We're fine. It's just a point that's being proven. Don't be scared. Okay. So next is black. I know black is pin 9, and I know pin 9 is ground, and I know ground isn't needed. So we just skip that ish. Wait a minute. 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 Where's black in the original pinout? Oh, pin 7. I'm an idiot. And we do need pin 7. So that's why you don't assume anything when you buy cables from cable manufacturers, because nothing is universal. Don't assume anything. Buy virgin butter. Buy... Okay, white. White is pin 9. Pin 9 gets nothing, so we skip it. Brown is pin 1, and it is null, so we skip it. Red is pin 3, and it gets a red wire. Oh, why am I cutting up this controller? Well, this is how you make an input display, Anna. So you have to cut up a video game controller extension cable and do what I'm doing to it, and then close it back up. That's how you make an input display cable. This just happens to be a $35 extension cable I'm cutting today. So, a little nervous, but we're fine. I'm doing great. Whoa. And that just leaves yellow, which is pin 6, and should get a black wire. Do I want to... Okay, guys. I have a spare violet... DuPont wire. But they're rare, man. I never find violet DuPont wires. Should I be nice and give him the V and Roy G Biv, or should I just give him a black wire? It's the rare violet wire, but it would be literally the end of the rainbow. You know what? I have to do this cable justice. Violet. Shintalk better thank me, man. This is a primo jump wire. Yeah, it's pretty neat stuff. I don't think I want to make input displays for people anymore, though, considering it's taken me 2 weeks to find the time / find the motivation to do this. So I decided, you know what, why don't I just make a video of me doing it from start to finish, then I can stop making input display wires, and people can do it themselves, and learn how to solder, or learn how to program, or learn how to accomplish something, or at least understand what it takes to make one of these. Because I don't charge, like, I hope people understand, like the people who have bought input displays from me, I don't charge you anything, man. All this work is like, I charge like $3 for it. Like, I don't charge y'all anything. But it's just because I'm a pushover. But that's why, I don't know, I'm tired of charging people for things that I do for fun. I don't want to do it anymore. So, today's the day we make the video. Okay, so that is it. This, at the very, very minimum, is all you need to make an input display. Congratulations. But I don't think this would be a very fun video unless we at least tested it out and make sure it works. And we're not done, by the way. I did say from start to finish. You all are going to see the entire thing. Let's just say, this might be involved. It's the best part. It's my favorite part. So you definitely are going to see the end. But for now, we're in a position where we should probably go ahead and test. Test. Hey. Alrighty. So the Saturn, like I said, you just plug it in like a normal controller extension cable still, except now you have these little DuPont wires to plug into a microcontroller. We'll be using the classic Arduino Uno today. Man, this is a nice Saturn extension. Wow. This is definitely nicer than I thought it was at first. Good stuff. Okay. Okay. I'm not showing you how to do Arduino stuff today too, by the way. That's not what this video covers. This is just making a cable. I'm not explaining software stuff today. Okay, so now perhaps you all might understand what I meant, if you didn't before, about why I specifically chose each color wire here. So, the RetroSpy project uses Arduino digital pins 2 through 8 for the Saturn. So instead of having to have the user of this product remember which order to plug each wire into, I made it color-coded to Roy G. Biv, so that you can just plug them in the rainbow order and you'll know it's the right order every time. So let's do that. Red, orange, yellow, green, blue, see, that makes things so much easier for having to plug this in. Cool, okay, so let me flash the firmware for this Arduino and give me a second. Do I not have the latest firmware? Man, this is obnoxious. Hold on. I know I have a good firmware around here somewhere. The 282 firmware should be fine. Should be fine. I think it's the last working one I had. Yeah, wow. Doesn't look the same, but we'll be fine. Okay. We want Arduino Uno on port 3. Upload firmware. Oh no. Okay. Easy. Let that compile. Okay, it's done compiling. So now we close this. Open up RetroSpy. Alright, and then pick Sega Saturn. Okie dokie. Window capture that ish. Alright. So there's our input display. Now, the moment we've all been waiting for. Well, maybe you all. This is the moment I've been waiting for. But it's going to be a good moment. Alright, let's see what happens. Yo, look at that. Would you look at that? So it's frozen, but I think that's because the console. Yeah, okay. Easy there. Easy there. Time to play the best Saturn game of all time, NHL 96. Maybe the only Saturn game I own, and I may have never played it. But yeah, I would say that works to me, guys. First try is hard to do with this, even for me, so I'm pretty proud of that for Saturn of all things, too. Okay, so we can move on to the next step. My favorite part. Well, the very last step is my favorite part. Everything before it I could do without, but we could probably do without it to begin with. But again, I want to show you all my standard for making these cables. You all can do whatever you want, but if I'm going to do this once, I'm going to show you how I do it, and I think I do it the good way. So that's how it be. All right. So now we have successfully figured out that our input display works, which is awesome. But you can't just leave it like this, right? There's some issues with that. So if you look here, we still have all of these exposed pieces of metal here. And if any of these touch, bad things can happen. For example, there's 2 exposed 5-volt lines and a ground line. If those touch, something is going to die. Okay? You have to do something about this. This is, I would say, the most important step in terms of safety and making sure that nothing breaks. You have to isolate these lines. You must isolate these lines. Okay? So there's a couple ways you can do this. When I first used to make these, I just wrapped each lead in electrical tape. But I since have moved to something different, which is heat shrink tubing. Heat shrink tubing. It makes it look nice. It keeps everything in there looking nice and tight. Heat shrink tubing. That's what I recommend. I can't recommend a size because depending on how many wires your controller uses, depends on what kind of heat shrink you need in terms of size and stuff like that. I have this 1/16 inch heat shrink that I use for non-DuPont leads because they're always going to be the same size. Although the Saturn one, the freaking copper's so big, this might not even work. Let's see, actually. Oh, no, that'll work, right? Just barely works, so yeah. So I use 1/16 every time for like those ones you don't, but everything else, it kind of just depends. So I'll get 2 pieces of this for those 2. And then we'll have to kind of figure it out on our own. And you'll probably very quickly figure out why this is my favorite part of doing a splice cable. You'll probably figure it out pretty quickly. Right, so what did we say this is called? This is called heat shrink tubing. Heat shrink. You need heat to shrink the tubing. So, I used to use, I'm not even kidding guys, this is how far I've come. Where is it? Where is it? Where is it? I'm going, hold on. Okay, this is how I used to reduce heat shrink tubing, guys. I used to use a cigarette lighter. I'd have to use a cigarette lighter and like hold it there and make sure that nothing gets burnt, including my finger. It was so bad, man. The heat shrink looks so bad. Don't use a cigarette lighter. It's a last case scenario kind of a deal, but don't use a cigarette lighter. Use a butane torch. Much better heat dispersal in a concentrated spot. And then it's also fun. Why not use a match? I don't know, DJ, you watch me do this first one and then tell me if you would do it with a match, okay? That's all I have to say about that. So, and you definitely want to keep the heat very far away do this. Take your time when you do this, because you don't want to char anything. Alright. And now you'll notice if I pull on this, it's not going anywhere, and it is fully protected, no metal exposed. So yeah, now we just need to do this for every wire, and I'll do the, like I said, these two ones that we didn't put DuPont wires on first, and then we'll figure out what to do from there. Why not use a heat gun slash hairdryer? You could definitely do that. But I don't like using heat guns for this because, again, we need the heat in a very specific spot and nowhere else. And the flame on this is conical, so it puts the heat in one spot. If you use a heat gun, it's dispersed heat, so it's going to go everywhere. If you're working on like a PCB or something, I think that's fine. But for how delicate these are, I wouldn't do that. Also, hello Jink, nice to see you. Long time no see. But yeah, in a spot, I would use a hairdryer over a cigarette lighter like I used to, for sure. Or a heat gun, I would definitely use that over a cigarette lighter. Yo, what's good, 40 watt? Yo, Sin. Yep, that's good. Alright, so those are the easy ones, unfortunately. This is where stuff gets hard. I need like a specific size heat shrink on average for these, and I don't really have one. I have like one bigger and one smaller, so hopefully I can make one of them work today. But I can never remember which one. I think it's like 1/8 inch for the DuPonts and then 1/4 inch for the controller. But I don't know. Let's see what I got. I think it's this 1/4 inch guy, or 1/8 inch guy, right? See, like, this is just barely enough, man, and it's not even, yeah. So this is exactly what we need, but it's just barely enough. I can't emphasize that enough. Okay. So now we'll cut this up. Have I tried turning it off and on again? Oh, we don't have any issues today. Everything's working first try somehow today. We just tested the cable to make sure it works, which it does, first try. On Saturn, which is probably the hardest cable to do, in my opinion, so I'm pretty happy about that. No turning on and off the power. Alright, so we'll need 3 more of those, so I guess I need another tube. And see, this is the problem. The only place I can find this size heat shrink is like, you have to buy it in a variety pack like this, and you only get 4 pieces. So I use 4 pieces and then have to buy a whole nother variety pack. It's kind of obnoxious. Unless I have a leftover piece from a previous project. Oh, no way! No way! Get the fuck out of here, dude. Right? Let's go. That's awesome. That's hype. I'm pretty excited about that. Although, it's only enough for 1, so I guess it didn't really matter anyway. I'm not hype anymore. I am not hype anymore. Yeah, I'm gonna be 1 short. Right? Wait a minute. Can we make this work? I think we can make this work. Oh, we're making this work. We're good. We don't have to sacrifice another piece. Good stuff. This is why you save things from other projects. Perfect. Okay, so that's 7 pieces. And we have 7 wires to cover. Let's do it. Oh, it's hype. I'm hype, Anna. This is my favorite part of the project. I am as hype as it gets when I'm making this. So, all the hype's here. The whole hype's here. And then this, again, I cannot emphasize enough how extremely careful you need to be when doing this step. Because, yeah, just don't char something you're not supposed to, please. Right, don't do that. Well, the torch is coming back on, so yes, the hype definitely returns. That one wasn't cooperating too well, but it should be good. That's super tight on the DuPont side. As long as it's tight on the DuPont side, it's not going to go anywhere, so... I know I'm listening to copyright-free music right now and everything, but this for real does sound like the freaking music for like an instructional video or like an introductory video to like working somewhere. Like it totally fits that vibe. Welcome to Bed Bath & Beyond. You know, like, I don't know, it just gives me those vibes. Or like one of those inspirational videos, like I haven't been on Facebook in years, but like I feel like when they had inspirational videos, like this is the kind of music that was playing in the background or something. Oh no! It's gone! It's gone! 40-watt range, went on to be working at the highest ranked tech company in the world. He got married and had 2 kids. Like, I mean, like, it totally gives me those vibes of, like, end of credits music or, you know, something like that. But I guess that's what CC music is anyway, or CCL music is anyway. And I guess that's why it's in all those videos. It all makes sense now. Yo, what's going on, Ricky? Ricky, I didn't even text you yesterday, but I almost did. The text was gonna say, "Dog, it's 3:30 and I just woke up. Enjoy the game." But I didn't send it. But yeah, for real, I got back from work at 3:30 yesterday. 3:30 p.m. is when I got back to work, or got back home from work. So there was 0 chance I was making that. I went to bed at 3:30 p.m. Yeah, he pitched like a beast, I heard, man. I want to do this yellow one last, because that's the one I exposed some wire on at the very beginning, so I want to take extra care to make sure that one gets covered. Although, in theory, if everything's covered, and except for one thing, then everything's covered, but I have standards, I don't know. I really would love to see how other people make their input displays, because they could be doing it so much better than me, for all I know, but I don't. Like, Pidge told me she puts her Arduino in like a... What did she say? She puts, like, I think it's an Arduino Nano, and she puts it in like in a cardboard box or something, almost like a matchbox. I'm just like, yeah, that's awesome. Especially if you want to keep costs down, but like... I couldn't sleep at night knowing I took money from someone and gave them in an Arduino and in a cardboard box. I don't know. I can't sleep at night. That's why I'm not making these anymore, because it's just a conflict of interest. I don't know. Like, I don't know. If you're at the point where you're taking money for something, and en masse at that, like, I don't know, you gotta have some standards. I guess people don't care. Maybe that's just it. Maybe people just don't care about quality like that. Because, like, I think that's where I got it all wrong when I was making these originally. It's like, I could go for quality, but then I'm having to charge so much money, right? So if someone sees me making input displays, and I'm charging 70 bucks a cable, whereas Pidge is charging 25, of course they're going to go with Pidge every single time, right? But imagine they don't go with Pidge. When a consumer who wants a input display looks for people to make them, they see someone with a $25 option and a $70 option. So of course they're going to go with the $25 option, and they're going to use the $25 option, and they're going to be happy with it. And I'm so happy for them, because for real, if I were in their situation, I would do the exact same thing. Problem is, though, you have the $75 option, which in this example is me, right? The problem with that is once the consumer goes with the $75 option, all of these expectations are there now, because, oh, well, I'm the other option, so am I getting my $70 other option worth out of it? No, you're getting the exact same thing, made by me the way I do it. And that's why I'm not making input displays anymore. Between that and just not having the motivation and time, I'm over it. Anna, super nice to see you. Take care. last one. Last wire, and then we get to do the big finale. The big finale, which is my favorite part of the project. Yo, Hactical, what's going on, bud? I'm making an input display. A Sega Saturn input display for Shintak, who you may or may not have met at RPG Lemon Break. He was the guy playing Saturn games all week, as we were playing Clone Hero all week. Okay, so this heat shrink will definitely cover that exposed stuff from earlier. Maybe not. Dang. I need it to be like 2 millimeters longer. That's unfortunate. Can I combo it? I don't really have anything to do that with, though. Okay, I'll figure it out. Cool? Yeah, I think it's cool. I'm done making these after... I have 2 more to make, and then I'm done making these. But I'm doing this video today so that other people can do it. At the moment, there's not really a full comprehensive guide to be making these. And this isn't really a guide. This is just showing how I do it from start to finish. But, if anything... If I'm not making these anymore, I don't have to think about dang. But if I'm not going to make them, who else will, right? But now, everyone knows how I make them. So, now I don't have to think about that anymore. Oh, I charred that pretty good there, didn't I? Oh well. Again, it's on the part that goes inside, so it doesn't really matter. Okay. So we need to do our 3rd of 4th test here. Now that we've isolated all of these, we need to do one final test before we do the last step, and then we'll do a test after that, and then we're done. So we just need to make sure that these work after isolating them. I know you all can't see me doing this, but you've already seen me do this, so I don't feel too bad about it. Yellow. Green. Blue. Indigo, violet. Power console on. And not working. Oh, tell me I just fried this Saturn. Tell me I just fried this Saturn. Well, I just fried my Sega Saturn, guys. Yep, I think I just fried the Saturn. Maybe it has a self-resetting fuse, but that did not. Let me see if I can smell it or something. Okay, it has a self-resetting fuse. We're good. Okay, and the input display works. So that's good. Okay. I don't know why that happened. The N64 has the same thing. I think if it detects a power overload or something like that, between the AC input or the controller, it has a break-in fuse that repairs itself. So I'd imagine most consoles after that probably had the same kind of thing. But yeah, as you can see, it works fine. It was probably just something I did with the... Because I wiggled the controller connection and that's when it happened. But like I'm wiggling both right now and nothing's happening. I'm even touching all the things I just touched. Like all the leads I just re-isolated and everything seems fine. I don't know why that happened, but I'm not too worried about it. It's the price of entry for doing these kinds of things is you have to be prepared for your Saturn to blow up, I guess. Okay, so now, my favorite part, the grand finale. If you all could guess, the final step is isolating everything now that we've isolated each connection. Yeah. Okay. Do I want the whole thing like that? Probably like that. Okay. So, yep, final step. We're going to use heat shrink to isolate everything so that it looks just like a nice clean splice cable. So you just put all the DuPont wires. I have a 1/4 inch, I believe this is, 1/4 inch heat shrink I'm using here. So just run all the DuPont wires through it. There we go. This might not be big enough. It's going to be so close. Wow, I probably don't even need to shrink this. Like, geez. Yeah. Okay. So it kind of looks like that, right? And remember, this is prime real estate when it comes to controller length, because this is where you're plugging in your controller. So I try to keep as much of that part of it as exposed as possible, just so that the user has as much freedom as possible. But anyway, now all we do is shrink this guy up and test it one more time, and we are done. All right. There's one more spot. Hold on. You think I'd miss you, didn't you? Not in a million years. All right. So there you go. All nice and clean. And then we'll do one more final test. Yellow. Green. Blue. Indigo. Violet. Alright, final test. Here we go. And the verdict. Oh, I should probably plug it into the console. I think you have to do that for this to work. I think you have to plug the controller into the console, I think. That's how you have to do this, right? I don't think the Sega Saturn had wireless controllers. If so, I should get one. There we go. Okay, our final product works. So yep, this one is done. So I guess I can try to show you all the whole thing, the finished product, and I'm done. I guess the next step is ship it to somebody, or play some video games or something. Cool. All right. Yeah, ignore all that, whatever, I don't care. Okay, so that's it. So we have our Splice cable here with all the DuPont wires that go into the Arduino. We have all of our work individually isolated and then completely isolated at the end with heat shrink at every step. You have the female end, which you plug your controller into, the DuPont wires that plug into the Arduino, and the male end that plugs into the console. And other than that, once you download RetroSpy and set it up, you're good to go. So that's it. I hope you all learned something. Thanks for watching.